Before I start the problems on this last section before our quiz, let me introduce chemical formulas and moles. That's the section we're talking about, the last part of section 7.2. Notice it's on page 236 through 240, and I'm calling this video 17. So the first thing I start with are chemical formulas, and that's how we make compounds. Both covalent compounds and ionic compounds. And for example, this first chemical formula is potassium bromide. Notice it's IBE, bromide. That means it's just that element all by itself. So I've got potassium, and I notice that it has a positive charge. It's in the first column, and you know everything in the first column is has one outer valent electron, and that's the easiest thing to get rid of. Once we get rid of that, we end up with a net positive charge. Bromide, on the other hand, over on the right-hand side of the periodic table, is able to pick up one single electron very easily, and therefore it picks up an electron and it creates a net negative charge. And the neat thing, when I look at this chemical formula, I see essentially I have one atom of potassium and one atom of bromide, and I can say that those atoms are in a 1-to-1 ratio. So one atom of K to one atom of bromide. And another formula that you're probably familiar with is H2O. H is a positive ion, and O is a 2 negative ion. And with the 2 negative ion, I'm going to need 2 of these positive ions in order to neutralize this and have a net neutral value. So you can see that our old formula for cross multiplying the exponents, so this plus is a 1, so I end up with 1 oxygen. I cross multiply, and the 2 comes down here and tells me I need 2 hydrogen. And I can look at the formula and quickly ascertain that it's in a 2-to-1 ratio, 2 parts of hydrogen to 1 part of oxygen. A couple of interesting vocabulary would be covalent compounds, and those form molecules. We call them molecules. And if you look at the formula on a covalent molecule, you can see that it will show you the number of atoms of each element. On the other hand, with an ionic compound, ionic compounds form formula units as to distinguish them from molecules. And that shows the number of ions with the plus and minus charge. Atoms, each atom has an atomic mass unit in grams per mole. On the periodic table we look and we find that, and usually it's to 3 to 5 decimal places, and for our practical purposes we're going to round off to 2 places on the periodic table. Compounds have molecular atomic mass units. That means we have to add up all of the atoms' atomic mass units to arrive at the molecular atomic mass units, and that would be the weight of 1 mole of this compound. So you can see I'd have to add several moles of different elements in order to get 1 mole of a molecular compound. I think that kind of covers the introduction. I'm going to start with the problems on page 239.